slow is cool. But the inconvenience is that they always make the announcement at the last minute. Sometimes I'm already on my way to drive to campus, and then I can't check my email, right? You will drive, you shouldn't. And then when I arrive, come to say, okay, campus shut down. So that's very interesting. But anyway, another reason is that rain is fine, but many people here, North Carolina or Labor State, don't know how to drive under slow weather. So that can cause big trouble.
Oh yeah.
For example, I remember early this year, I attended a conference in Savannah in February. There's a huge slow on February. And when I drive in I-95, people are driving crazy. I don't know why. Maybe they want to have slow weather, big slow. They want to go back home as soon as possible. But totally wrong decision, right? Slow weather, you have to drive very slow. So I was the person drive almost slowest in I-95. I don't understand because I have this experience back to Indiana. I have a big accident when I drive in I-65 before. I know that you can't drive too fast during heavy slow weather, but some people don't know. So I can understand why we want to shut down the campus because students, faculty commutes for a long distance. Maybe you know how to control your speed. You know that you're very cautious, but you can't control some bad heavy drivers on the road. So, but yeah, that's my suggestion. Okay. One announcement, have you guys checked the Blackboard or check your email? I already signed a group study yesterday evening. Well, based on some student preference. For the rest, I just assigned this randomly. Okay, we have 4 groups. So each group has 4 or 5 teammates. And each group has been assigned a case study. So there are 2 major tasks for the case study. First, you have to write the case study reports, at least 5 pages, to analyze your case by qualitative or quantitative information underneath, and summarize your results. The second task is prepare about 12 minutes presentation. Most students use PowerPoint. Some other students use some other software or some other formats of the document, which is fine. It's your choice. Right? Because we have 4 groups, so each group have about 12 minutes. And, the due dates of both the reports and also in-class presentation is next Monday. So it's October 12th. It's a Monday. Okay? And everyone in the group has to come here to present. It's not just one representative of one group. Everybody has to present, has to speak out. That's a requirement. Okay? Don't tell me you are too shy. You can't be too shy if you are in school of business. Right? So come here to make a presentation. And make sure everyone contributes to the reports and the presentation. Because that's the way I grade. When the final report you guys submit to me, well, you have to list all the names in your teammates. If anybody is not in the list, I would assume that other teammates think you has not contributed to the reports. That's the reason your name is not listed in the cover page of your reports. If that's happened, then you get 0 points. Because it's a teamwork, so it's very important. Everybody has to contribute. But I hope if there's something happen, for example, you guys call a meeting, there's another teammate never attend, let me know in advance. Don't wait for last minute. Okay, just don't put his or her name on the reports. Let me know probably even Thursday, Friday, we can do something. Okay, that's my suggestion. Any questions? Comments? I hope I will see a great presentation on next Monday. Okay, continue our study on chapter 10, the quality control. The control process, we have introduced the sampling, and if there's something also sampling distribution, we take corrective action. But those are only a part of control process. Here is the steps required for effective control. First, have to define, okay, what should be controlled. That's the height, weight, miles per gallon. What are important for you, for your products? Okay. Second, if we know that this feature is so important, right? Like gasoline efficiency is very important for the car. Then how to measure your efficiency? We know it's miles per gallon. That's the measurement, right? Then we compile. That must be a standard. If you don't know whether you perform well for your car for miles per gallon, probably you want to see some similar cars in the markets to see what are their performance. Yes, that's your standard. And it establishes a definition of output control. And we have discussed, if you claim your miles per gallon is 30 miles per gallon, well, everybody understands that there must be some fluctuation about your cars. Nobody expects every car has the same 30 miles per gallon. So it's your job to discover, to define which range this makes sense. Maybe some company has this quality control, 28 to 32. Maybe some other company have 26 to 34. Why is it? You have to collect your data and evaluate your product's stability to see what is your range. And if you find some non-random variation, some car is out of the boundary, and you have to take corrective action. Monitor is continual improvements to verify the problem and continue to monitor this. Okay, so now we'll introduce the control charts. How to get these control charts? How to build these control charts? Because without these control charts, we can't monitor our performance. So control charts is a time-ordered plot of representative sample statistics obtained from an ongoing process. So first, it's ordered plot, which is in fact is a time series plot. If you still remember chapter 3, right? It's the time series plot of sample statistics such as sample mean. So like day 1, you collect 10 cars, you test these 10 cars miles per gallon. Day 2, you collect another 10 new cars and calculate sample mean miles per gallon for these new 10 cars. Continue to do that. Then you have a plot of every sample miles per gallon for every day. So then you can use this to distinguish between the random and non-random variation. The control limit is the dividing lines between the random and non-random deviation. We have the upper and lower control limits, which in fact we are built in 5 minutes. So if you one day you collect another 10 car, you also control, like say 35, which is not bad, right? You, for whatever reason, you have one day the 10 cars, the average miles per gallon is 35. You think cars will like that, but still, we have to dig out why today our outputs, our production of the cars have 35 miles per gallon. Maybe that's good news. You find some way to improve your miles per gallon. So, but anyhow, you should dig out the reason. Right? So this is control charts. You can see so it's a time series. Every day you collect the sample mean. Right? So this red dots is not just one sample point. It's a sample mean collected by several different sample points. It can be 10 cars, 20 cars, 20 people, 100 people every day, and then until the 12th day, then also control. You should evaluate why it's happened. So you can see each point represents a sample of n observation. So n definitely is most likely is greater than 1, so it's a big number. And there's two concepts. Type 1 and type 2 error. Okay. These concepts are, initially, I think this is the first time you guys see this term. It's going to be very confusing. But if you are in the statistics departments, that's also a very fundamental theory or idea students have to know. So, type 1 error is that you make a conclusion. A process is not in control when it actually is, which means you make a mistake. Right? Why you make a mistake? Because we use probability and statistics. That's the reason you make a mistake. You say the probability of reject the null hypothesis when the null hypothesis is true. Well, that can be a risk. Let's see why it can happen. You think about that. let's say we want to analyze the human being's height, let's say US. We want to analyze the US, people living in US, the average height, or what is the normal height of a person. If you're too long or too short, too tall or too short, that can be a problem. Maybe indications of some disease, right? That's the reason. Okay, then we collect a lot of data. We find, okay, that's maybe, I don't know, give me a range you think is a normal height of a person.
Are we talking about male or female?
Let's say male.
5'10".
5'10"?
Yeah.
I mean the range. So you mean under 5'10" is abnormal?
Oh, jeez.
5 what? Let's say whatever, 5'2" to 6'1", something like that. What is the height of Shaquille O'Neal? How tall of him? So about that?
You said Shaq?
Yeah.
Oh, he's way taller than that. He's
Yeah, right. So
7'2".
what about LeBron James?
LeBron, he's 6'8", 6'9".
Right.
5'8".
As even say make it 6'7". Right? LeBron James is 6'8".
Yeah, he's 6'8".
Shaq probably
About
6'7".
No, he's 7'2".
7'2". Okay.
Yeah.
Very good. Then you can see the problem here, right? We collect the data.
Oh.
We analyze data. We think, okay, that is the normal range of person. If you are out of this range, that can be indication you have some disease. Well, we can see that, right? But that can happen. That can happen. So some special disease really that you come very tall. But you can see LeBron James. So it's not 7'10", 7'2", right? That's for example, Shaquille O'Neal. If you just see the height, you didn't know this person. You just see the height or the weight of this person. You maybe think, okay, maybe something wrong. But in fact, if you know Shaq, he's very healthy, probably one of the most healthy person in the world, right? Very strong. So there's nothing wrong with this person. Weight is the same thing. If you just see the weight without knowing the height, you also can just see the weight of Shaquille O'Neal. You think definitely it's overweight. Or maybe he is overweight, but definitely it's really out of control. This person's weight, right? But if you know some other parameters like height, that's normal, right? Especially LeBron James, the weight is totally normal. So that's the thing why we make this error, type 1 error. If we just see one attribute, the height, weight, or like income level, whatever, you think, okay, for example, your income is 0. Let's say your income is 0 per year. We go to church, this person is out of control, very poor. But you don't know he has a very rich parent. He doesn't have to work at all. You don't know the picture. You don't know that, right? So that's one thing, is that you make this conclusion, okay, this is out of control. Okay, Shaq's height, Shaq's weight is out of control. But in fact, it's not. Why it's not? Because for any process, for any attribute like a human being, our height, weight, we follow a normal distribution, right? Remember? We follow a normal distribution. But when we build our control charts, we collect a sample. Like sample can be any student. We collect sample from student from UNCP, but I mean nobody is higher than Shaquille O'Neal in UNC Pembroke. So we never reach this sample point. So when we collect sample, most likely we have the sample points in the middle of normal distribution. And then when the new point come out, like Shaq come out, he is in the upper tail of this normal distribution, which is normal. We know that. There must be some extreme case follow this normal distribution. But we never collect. Then we draw the conclusion, okay, Shaq is not normal. Because based on what 6,000 sample collects in UNC Pembroke, I never see this point. Then it's definitely bias. But what's the problem? With statistics. If we collect any single data point in US, where we have more than 300 million people, then we can cover people like Shaquille O'Neal. But we can't, right? Because time, money, we can't collect all the data points. But for using the sample, we will have this error happen. Extreme case. So that's the reason. It's clear for you guys? I hope you understand. Mm-hmm. So type 1 is because, naturally speaking, most process follow normal distribution, right? Like miles per gallon. Sometimes it really has a car have very high or very low miles per gallon. Nothing wrong with your production line. Okay, this car just has 20 miles per gallon. You design 30. You dig really hard, but nothing wrong. It just has some random variation. Okay, a particular car is only have 20 miles per gallon. Nothing wrong with the machine, nothing wrong with your employee, but it can happen. Right? Loads very frequent, but it can happen. Then you make a conclusion and say, oh, there's something wrong with our production line. Why this car only have 20 miles per gallon? In fact, you make the error. But still, the suggestion, when you find this abnormal number, you should dig out. Maybe, but you should know that if you dig very hard, there's nothing wrong with it, because that's a type 1 error. That's normal. That's its extreme case, but still normal. On the other hand, it's type 2 error. You say the process is in control when it is not. The same thing, right? You think you collect your data point. Think about miles per gallon, right? You collect data points. Okay, each data point you collect is under the range. Let's say your range is 28 to 32, right? So your point is always in the range. It's in the range. But you may already ignore that you already have problem on your production. But this concept reflects in the charts. The reason is every single point collect is a sample, right? You produce 1,000 cars per day, you collect 10 cars. For example, this point, it's very, let's say this point, it's close to the lower bound. Maybe today's production really has some problem. Well, if you really collect this 1,000 cars produced today, maybe it's already below, it's here, 25 some point. But by luckily or unluckily, you collect 10 data points, they are still in this range, under control, which you think no problem. But in fact, this consumer's risk. Consumer buy the car you produce in this particular day probably have this problem, lower miles per gallon. Why? Still, statistics. We use a sample to evaluate the population. Anytime we use a sample, we know that we have risk. This sample first can be type 1 error, okay, doesn't cover the upper or lower tail normal distribution. Or type 2 error, okay, it tell us, okay, it's under control, but in fact, your sample size is small. It's still, in fact, it's already out of control. So the basic idea for these two areas is that we use statistical tool to evaluate our population's property, which can be biased for sure. Right? But we have to use statistics. Why? Because it's cheaper. Right? We can't analyze each single point. There's no way. Sometimes we can, but it's really hard. But when you use statistics, when you choose samples, you know that you can have these two errors. Sometimes can't avoid that. So type 1 error, let's say if Shaq and LeBron James, they belong to this upper tail, height or weight, right? They are totally normal, okay? But out of control for some type of charts. And here is the observation of the sample distribution. You collect sample, that is the sample mean, and then here is the real population mean. Sample mean, real population mean, but these are all under control of these sample points. Okay, now we begin to do some statistics. We have talked about these control charts a lot. How to build a control charts? And what type of control charts we will learn in this chapter or use in the industry? The first one, the first big category is the variables control charts. So variables generate data that can be measured, such as mean or range. So mean, I believe everybody knows what's the definition of mean, right? What's about range? Give you a sample. Like say, what does this mean for range? For example, we have 18 students here. I collect your information for your weights, right? Then what's the range of the weights of this class?
Would be the maximum minus the minimum.
That's right. Like Jonathan said, range is the maximum minus minimum, right? Mean, everybody know. What's the definition of mean? Average. Right. Okay, then we know that these two variables are very important, right? For like the average performance is very important. Customer really need to know average. But on the other hand, the range is also important because customers most likely they don't like big fluctuation. The smaller the range, the better feeling of the customer. But it's the usual situation, right? So we will use the mean control charts to monitor the central tendency, so average performance of a process. We call it X bar. So it's X bar charts. And the range control charts used to monitor the process dispersion fluctuation. It's R charts. We know that these two variables are very important for customers. And we'll see how to build these two charts. First, introduce some notations. X double bar is the average of sample mean. It's equal to sum together I from 1 to k x I bar divided by k. Well, x I bar is the mean of sample I. So who can explain to me x double bar? You understand it? What does it mean for x double bar?
Once you take the means of all the samples, you take those values and find the mean of those.
That's right. So it's the mean of the mean, right? Already you have a sample mean, and take the average of the sample mean. I would say it's the grand average. You take all the number, throw it, and then take the average. That is x double bar. Right? And R bar is easy to understand. So each sample you have the Ri. Right? You collect each sample every day. You collect the sample, have Ri. You just take the average of the sample range. You get the R bar. Okay, we have these two concepts. Then we need to build the control charts first for X bar. So X bar we know is used to monitor the central tendency of a process if the standard deviation process is known. Which means if you know the standard deviation sigma of the process, if that's known, then here is the way to build the control charts for the X bar. So you first need to calculate sigma X bar, which is a sample standard deviation. To calculate that is sigma divided by square root of n. Who can tell me what does n represent?
So number of samples.
No.
Oh, right.
What does n mean?
Observations.
Yeah, there's sample size. How many observations you have in each sample? The number of samples, in fact, we have introduced on last page, is k, right? Number of samples. I want to make you guys clear about that. So now we talk about two numbers. First, each sample, how many data points? Like here we have 18 students. Another class maybe 20 students. Well, each sample, that's the sample size. And then we collect how many sessions? That is k. Okay, we have this information, sigma divided by square root of n, we get the sigma x bar, which is standard deviation of distribution of sample mean. And then build the control chart becomes simple. So the upper control limit for x bar is equal to the grand average x double bar plus z value times sigma x bar. While the lower control limit is x double bar minus z times sigma x bar. Now, the only question we have is here, z value. We now know how to calculate x double bar, we know how to calculate sigma x bar. What does z mean? Anybody? I know it's my job, but I will do my job later. So first want to ask you guys. I know it's my job.
Z score.
Z what? Z score. So what does Z score mean? How do you find Z score?
The normal distribution.
Normal, very good. Very good. It's a normal distribution value. So which means you go to normal table, yeah, you have to use that in your homework and exam. So we have a normal distribution table in appendix A, appendix B is a normal distribution table. So when you do your homework, just refer to appendix B in your textbook. And how do you find the Z value? Is that based on your criteria. Different company, different product has different Z value. The reason is that Z value determine how tight you want to control your measurement. You think about, say, if miles per gallon, right? If let's say BMW, they have very tight control that. They will say, okay, Z value equal to 1. Well, let's say it's pretty sensitive, right? So if let's say Ford, okay, let's say Ford has a little bit looser control. They say Z value equal to 2. That means you have a larger range for the control of miles per gallon for Ford's car than BMW's cars. Right? So it's your criteria. You will determine your company. You will determine the Z value here. Okay, and then you get the control charts. Another situation, And this is a more common situation. If the standard deviation of process is unknown, which is normal, right? How do we know that? We produce a car, especially a new model. We don't know the miles per gallon. We have no idea what is the deviation, standard deviation of miles per gallon. Then we can't use the information of sigma here, which you have the assumption you know the process standard deviation. If you don't know, you still can build a control chart. It's by upper control limit x double bar plus A2 R bar. R bar is the mean of the range. Lower control limit is x double bar minus A2 R bar. Well, we will have an example very soon. If you haven't printed out the slide, you probably should write down the formula. So A2 is a control chart factor based on sample size n. If you have a textbook, you can find the on table 10.3 on page 433. Page 433, on this table, it has been shown the A2 value for each sample size n. For example, if sample size equal to 10, what is A2? Anybody can tell me? 0.31, that's correct, yeah. So you can use this table to simply find A2 for a given sample size. Yeah? You know, all the things we need to know to build the X double chart, X double bar chart. And for R charts, it's even simpler. So the control charts, the upper control limit for the control charts is R bar times D4, and lower control limit is R bar times D3. The same table on page 433. Also, for given sample size, it showed D3 and D4. Okay, so that is. Now, example. So a quality inspector took 5 samples.
Can you go back a slide real fast?
Okay, sure. This one?
Yeah.
So D4 R bar, D3 R bar. Lower and upper control. Good. Anybody guess also this one? Everyone guess this formula? A2 plus A2 R bar minus A2 R bar. And the first one is a little bit complex. First one? Everyone? That's the reason I suggest you can print out the slides before coming to the class. Everyone gets the formula? If you have the slides, you have no problem, right? Okay, let's move to the example. A quality inspector took 5 samples, so each column represents a sample. Make sure that you are not confused about that. Each column represents a sample. So each sample has 4 observations. So it's 1, 2, 3, 4. Each row is the sample points of a sample, right? It's not some student may get confused. Okay, this is sample 1, 2, 3, 4. No, this is the 4 observation of each sample. Right? Of the length of time for glue to dry in minutes from previous experience, well, we know the standard deviation of a process is 0.02 minutes. And the goal is to obtain 3 sigma control limits for means of future times. Okay, then we want to have the 3 sigma control limits of the future time. The first question is we have 2 formulas to build this mean control charts. We know that is mean control charts, right? Control limits for means. And the first formula and the second formula, which one we should use in this situation?
First one, because you have the standard deviation.
Great. And Jack said, if you haven't written down this formula, please, because you have to use this formula for this example. Because we know the standard deviation of how long the glue will dry. Okay, we know the standard deviation. Then we should use the first formula. The second page formula is that when we don't know the standard deviation of process. Now since we know that, we follow this formula to calculate the sigma x bar, and then calculate upper and lower control limits. Everybody gets the formula? Okay. Waiting. Take your time. Everyone guess? Okay. Okay, let's see the example. So, first, the formula. Right? The formula is that we have to first calculate the sigma x bar, which is equal to sigma divided by square root over 2. And then we can upper control limits, build upper control limits is equal to x double bar, which I don't think you have any problem to build that, plus z value sigma x bar, well, lower control limit is equal to x double bar minus z value sigma x bar. Because many students haven't taken the textbook here, so I first want to discuss the z value before I let you guys to continue to do this question. How to determine the z value here we use? We know that we can calculate x double bar, the sigma x bar later. Z value, how to determine that?
You can reference it in the book.
Reference in the book. And how to use the reference in the book?
N-1 and what, like standard deviation, right?
How do you guess that? Any information provided here?
It's like N-1 base, so it's number of samples minus 1, right? And then
That's, I'm talking about the z value, not the standard deviation. Here, in the formula, we have to determine the z value here. How to determine the z value? How to determine the z value?
you use the chart with, but
Yeah, that's correct. But how to use the chart? I can give you the chart now. How to use the chart?
isn't it based off of N-1 and
No exact check. No n minus one has nothing to do with n, but has some information to do with the information provided here. Which information?
Oh, that 0.02.
No,
These on the table, the numbers on the table.
no. Any volunteer?
10.3 sigma.
3 sigma. 3 sigma. Okay, so start sentence. 3 sigma. What does 3 sigma mean?
That's the range, pretty much.
What does sigma mean? Sigma is the standard deviation, right?
mean
When we talk about 3 sigma, it means
means you're using the 85 or the
yeah, but yeah, you can find the chart here. Basically, 3 sigma, you go to the normal distribution chart. Okay, you find that if you have a textbook, please do the same thing with me. So, for example, so 3 sigma, you want to go to the chart to find what's the z value. What's the z value equal to 3 here, this table, and what's the corresponding probability? That's the thing you want to build, which is z value. Right? So 3 sigma, that's z. It's nothing but what? If that's already given 3 sigma, it's very straightforward. Z equal to. Okay, let's say that's what. If it's given probability, let's say you have probability control, let's say 95%, you will go to the table to find the z value. But if here in this question it's very straightforward, just equal to z equal to what? 3. Yeah, but in your exam, they may ask in that way. They say they want to have control of 95% percentile control. Then what you have to do is that to go to your table appendix to find the corresponding z value. Right? To find corresponding z value. But this question is simple. Right? But still want to explain that to you because sometimes you will see this condition. But this one is simple because z value is how many sigmas you want to control. How many standard deviation you can control? 3 sigma. I believe many of you guys have heard about the notation of the 6 sigma. Have anybody heard about that 6 sigma before? Nobody? 6 sigma is the idea raised by Toyota. I think you must heard about that, right? Yeah, right. So you should raise your hand. 6 sigma is the idea raised by Toyota that they want to have very tight control of their quality, which is a negative 3 sigma and a positive 3 sigma. So basically, for the normal distribution, which is the 3 standard deviation below the mean or 3 standard deviation above the mean. That they think is a tight control. But different company like here is also 6 sigma because 3 up and 3 lower. But different company may have like 4 sigma control, like 8 sigma control. That's depends your criteria. So this particular product they want to control by 3 sigma. So above. Okay, so that's C equal to 3. Now I think you have all the information you need to know to build this control chart. I will give you guys 8 minutes. I think it should be enough. Try to build the control chart. First calculate X double bar and then sigma X bar.
Okay, so
Umbrella from nose. This umbrella from nose.
Umbrella from your nose.
No? Yeah. Like as a similar umbrella from nose.
This is from the bookstore.
Bookstore.
Yeah.
Similar style.
Yeah.
And then this.
You said, why you doing this, man? Cause
been, how long has it been since I did stats?
man,
It was
that was like 2 years ago.
For me, it was last year. It was like,
X bar.
I'm trying to remember. That's, I don't know if that's what I was talking about how the normal distributions said for me, I was like, yes, this was.
Hard because I couldn't understand them.
Five.
So some
That's right.
Divided by 5.
Here's the formula.
Alright, so I'm gonna figure out something. It's like good. I don't know. The formula is inside. I don't know how to like do it. I wish we had like an example of it or a so then we do.
Yeah, we have X bar for each sample, right?
I mean, it's some of the small people in the class.
In fact, X1 bar, which is sample 1.
I was like, man, let me let them do it.
Until 12.12
They're
is
just
the
trying to kill my head.
fifth sample bar.
Well,
That's
not to do it, but
the mean.
try to go through
And then
it.
use the formula. How do you calculate X sample bar? It's equal to summation of X bar. The summation of the last row divided by 5. Because we have 5 samples. Right?
You just take all of them and divide by 5.
Yeah, because each one is each sample. That's X double bar is Yeah, yeah.
until he comes around, looks at my face and then I'm like,
Both up and lower have that.
today's not my go. What'd you get? Already missed it.
You missed the finish?
First one, yeah, man. Set my one.
Early top.
You are struggling. You still I am.
What the heck?
International management.
I'm struggling to get there.
You started on your paper yet?
Okay, so
I'm
dang,
telling
this
you,
class,
man.
the case study is 2 weeks from.
I gotta start
Not next month, the week after.
Like I'm talking
Okay.
like one after the other.
Oh wait, that's basically 1 week.
on different devices.
Yeah.
Yeah, no, that's
Dang.
probably gonna be like Sigma.
So your group members are going to start talking to
Why? You can't remember why you guys some desert.
One of my group members is not even here.
either of us. My niggas was in the back row. He ain't here
Yeah,
tonight.
yeah, I woke
This is
up.
great.
What are you doing next
Squares of what?
On top of it.
Money?
I'm the case study. Is that already on Blackboard?
You got a coach.
What you got doing?
I got the same bro.
Same thing?
Yeah, cause
What is squares of money?
cause
We have to.
Yeah.
No,
And
if you wanna
What is
come
that? It's the sample size.
coach for the weekend.
Yeah, when
It's
you
not
lower
any
it.
cosmetics and stuff like
Each
that.
sample size, each sample,
Bro,
most
you
of
trying to
them.
make grades, bro. The best bet is you on the road.
And then I can't, yeah, 'cause that means I'm gonna have to skip
Because,
medicine.
yeah, sample size.
Class to that.
Think about it, these samples are collected independently. You can't say this is a big sample.
It's like a 2.5 hour
5
drive.
samples,
Two
each sample
of the way.
size.
Yeah.
Gotcha.
This,
Let's say you left here this last one. Start.
I think about like 1:30.
132 depending on traffic.
I'm still figuring it out. Like I'm trying to figure it out. Like, okay, basically, I know there's a way to put the formula into the actual calculator, correct?
Cheater.
You don't want to do that way because you want to go to step by step. First calculate x double bar, and then it's not cheater, but it's hard to guess this way. First guess x double bar.
All right, so
X double bar is you take the average of last row. Yeah, last row. It's not the column.
oh, I'm sorry.
Yeah, last row is the sample mean for each sample. We have 5 sample, right? Each sample have a sample mean. That's we calculate x double bar, and then you next step you calculate sigma x bar, and you should get.
Oh yeah, the row. Oh yeah, never mind.
The column is the sample, and the row is the
Oh, going
each.
across.
Yeah.
Okay. Okay, that's a lot easier.
No.
That's 12.
What's that? Is that your
Plus
range
12.
chart?
Oh,
What's your mean chart? Oh, goes the range chart. Right, go to the next step or? Yeah, we do have the next step is a range chart, but why is the mean chart? Yeah,
you said.
you confuse yourself. We want to build a mean chart. You follow this one?
All right. so
Double bar plus
Yeah.
sigma x bar.
Standard deviation of the process.
now.
Okay. Sigma, you calculate
I
wrong
guess go by the formula. Double bar
because I see your link to this one.
plus z equals 3.
Oh no, Sigma did
Double
I
plus
did
3.
Yeah, it's this one.
So there's 3.
3?
0.02.
You know 3.
This one I wish I had my
This
stats
is
lab right now.
what is sigma?
My stats lab.
Stand deviation.
That's the one that pretty much helped me to understand the
Points
whole
oh, that's
thing.
right.
Ah, sure.
That's correct. Yeah. Z is 3. Z is 3. So 3 sigma is z value. Z equal to 3. And then we should calculate the sigma as well. So what is sigma?
I just,
Yeah. Great. And what is n?
next is 5.
It's gonna be a lot of fun.
This is just gonna be so much fun. You can't see.
Yeah, one.
Yeah, can we go I'm just not getting it. I understood what you told him about the last part when you said copper.
Yeah, I forgot to multiply it.
Average that. I mean, like, you plug it into the formula, the UCL formula. Like, I'm not in that.
You first calculate x double bar and try to calculate sigma x bar.
That's what I get.
Sigma x bar has a formula on the first line of the whiteboard, right? Sigma divided by square root of n. What is sigma? That's great. And what's the number of n? Sample size. No. Each sample. Look at the column. One column is correspond to one sample, right? So each sample has how many observations?
I thought it'd be 5 because
4, right? The last row is just the mean sample calculation, so you get all the information you need to calculate it, right? Okay.
So, let me see. Let me calculate the
Really?
rows
So
Four
your
rows.
problem is that what
I'm
is
gonna
sigma to
include
use?
the sigma, the point 2.
Oh, no,
You didn't divide it like
Times all 4. Average that. Or add together.
you the weightage
the regular
makes
things, say average.
I could
when you write this down,
So then what would the 12
Yeah,
be?
is that what it's
sometimes
Yeah, okay, okay.
sigma is fine.
I did go out there 12, 11,
This
3
is
times.
six.
Divided by square root of
2.
so
Yeah, I guess
okay.
that's
Which
which
Not much.
given is
Hang it
sigma.
out.
I read it.
But I knew there was a reason.
I was trying to get into the first class that I would.
No problem. Okay,
That
let,
got crazy.
Square root divided by.
some students have finished that, and some students are still struggling. Let's go. Oh, sorry, I shouldn't erase that. But anyway, let's do that together.
8, 9.
Any volunteer is not an easy one, but it's not a hard one. Jonas.
So you're gonna, your first step is you're gonna use that formula. So you're gonna do 0.02
Okay.
divided by the sample mean, which is the square root of 4.
No, it's the sample mean. Sample.
The sample size.
Sample size.
Yeah,
right.
sample size. Sorry.
Sample size.
And then
It's
just
equal to
square root of
4.
4.
Right. The reason why sample size equal to 4. And the other one can tell me why sample size equal to 4. Why is those 5? I see that's 1, 2, 3, or 4, 5. Am I right?
No, that's just 5 category.
Yeah, 5. No, 5. No, 5 samples. Right? We have 5 samples. I know it's confusing, but I have to explain again. We have 5 samples. Each sample has 4 observations, which means the sample size equal to 4 for each sample. Right? 1, 2, 3, 4 observation. But we have 5 samples, which means think about that. Day 1 we have a sample. Day 2 until day 5. Each day we collect a sample, right? Each day we collect 4 data points. So the sample size equal to 4. But the number of samples equal to 5. I hope that's what I can explain. I'm not sure whether it's clear enough. But that's, we have total 5 different samples. In each sample we have 4 observations, which means the sample size n equal to 4. It's clear?
0.03.
Okay. And you guess Jonathan is equal to
0.01.
That's great. The next one you have to calculate H double bar, right? How do you do that?
So it's the mean of the mean. So you're gonna take that one divided by 5.
In this question, it's already given for each sample mean. If you don't have this sample mean, the simple way is that you throw all these 20 data points, add them together, divide by 20, you'll get the same thing, right? But it's already given here, so save your time. So you just add them together. 12.10 plus 12 plus 12.11 divided by 5.
So you should get a total of 12.126.
12 points.
Is it 1 1?
That's 1
Okay.
1. Yeah. Okay. The final step, just plug in.
Yep.
So it's x double bar plus sigma x bar z value. So you have 12.11 times plus 3, right? Times 0.01. So you get 12.14. And the lower control limit is the same way. You get 12.11 minus 3 times 0.01. You get 12.08. Am I right?
Yes.
Am I right? Great. Okay, that's the end of today's class. I'll see you guys on next Monday. You guys kind of know each other for your teammates.